Okay, so example number 6 is this. It is telling us that you have x equals cosine t over 2 and y equals sine t over 2. You want to plot this one. T will be between 0 to 2 pi. So you can see 0 to 2 pi is actually this angle, right? 0 to 2 pi. And if you look at it, you will see that this position here is 3 o'clock. This position here is 12 o'clock. This position here is 9 o'clock. And that one here is 6 o'clock. So we just want to see something, what is going on. Let me see t equals 0. When I say t equals 0, what happens to x? It will be cosine 0. Cosine 0 is 1. And then y equals sine 0. Sine 0 is 0. So 1, 0 is somewhere here, right? So this is initial 1, 0. Now I said t equals 2 pi. When t equals 2 pi, x will be cosine 2 pi by 2. I'm putting t equals 2 pi, which is cosine pi. So cosine pi is -1, you know that. And then y will be sine pi, again 2 pi over 2. So sine pi is 0. So -1, 0 is somewhere here. Okay, and we are moving in this direction. So then it is going like this. So then we can say that starts at 3 o'clock and ends at 9 o'clock. Counterclockwise direction. Yeah. Derivative integral and application. So this is in terms of parametric form. So first of all, I want to mention a chain rule. Usually if I say dy dx, can I say then this one is dy dt and then dt dx, right? You have seen chain rule kind of this form. And then application area is something like a to b y dx. We usually know like that, yeah? This is area function, where a lesser or equals x lesser or equals b according to this form. Now in the parametric form we say x equals say ft and y equals say gt. So we just want to see what happens. Now say that t is between c and d. T is between c and d when x is between a and b. Now my y is gt. So then area will be again c to d. Now limit will change because it is on t. So y is gt. And now dx. So you have x equals ft. So what is my dx dt? Dx dt will be f prime t. And then you can see your dx is f prime t dt. Okay. So that exactly I need to replace here. Dx will be f prime t dt. So this is the formula we will be using when we say application of derivative integral. So this is integral here. If you are given parametric form without transferring this one to Cartesian, if you can transfer this onto Cartesian, then you can use this form. But if you don't want to transfer this onto Cartesian, just use parametric, then you have to use this shape. So gt is coming because y is there. But if your limit is given here in terms of y, then it will be x dy. Accordingly, formula will change. we'll get parametric form. So we are saying x is the function of t, ft, and y is the function of t, we call it gt. Now, length of a curve, we know from a to b square root of 1 plus dy dx squared and then dx, right? We know that. This was the formula we have seen in previous sections when you are looking for arc length. Now this is number 3, arc length. Now what happens, we have seen dy dx is actually this one, or you can say this is like dy dt over dx dt. So then formula will change now, and we mentioned that t is going between c and d, so the integral will be between c and d. Now look at here, you have this one here, 1 plus this, so it will change now dy dt over dx dt, so it will be squared. And then we'll make further simplifications. At the end you will see that this one will come out like c to d square root of dx dt squared plus dy dt squared dt. After simplification, you can see that if you square it, simplify it, you automatically will see that dx will cancel out and dt will stay. Okay, so these are 3 forms.